They all say good luck, Drew. Yeah, we're all happy. We're gonna watch it when it comes on, Drew. So whenever that happens, we're all gonna watch it in class. Who needs to do math that day? He's competing. We're all gonna watch him compete. We'll see if it's in this class. Yeah. Okay. We learned about segments and sectors of a triangle. No, not a triangle. What shape are we doing? Circles. Yep. I'm gonna have to delete all of this, sadly. And clear. Okay. We are moving on to another line on a triangle. Oh my god, on a circle. I need to like end this recording and we do it. Okay, we are going back to 10.2. We're talking about tangent lines to a circle. So line tangent to a circle. So let's first draw a circle. Do you guys want washers? Okay, let's draw a circle. You guys get washers. I don't think it's gonna work if I use washers. Nope. Okay, not doing that. Okay, we have our circle. Then I'm going to draw a line on my circle. What do we call the line I just drew? Yes, our radius. And then now I'm going to draw my tangent line. This is going to be a straight line that only touches the circle at one point. That's it. It only touches that circle at one point. And because it only touches at one point, it makes a 90-degree angle with the radius right there. And I'm just going to label some of these. This is circle C. This point right there that touches, let's call it X. And this will be line M. So this right here is the tangent line. So a line tangent, ooh, I'm not liking this color. Tangent to the circle intersects the circle at one point. At exactly one point. And makes a 90-degree angle with the radius. Could also be the diameter, but right now we have the radius drawn. So this point is called the point of tangency. So Vincent, what is our point of tangency in my image here? Yeah, that point right where they cross, right where they intersect, is the point of tangency. Now this goes directly into a theorem, which is going to be our first theorem. There's going to be a lot of theorems in this chapter. We'll get like a formula sheet for all of them. It's not really a formula sheet, a theorem sheet. But this is the first one, so we don't have to keep looking back. So theorem 10.1 plus its converse. A lot of these theorems are going to be an if and only if, so we can go both ways. So this is 10.1. So if line M from above is tangent to circle, in this case it's C. This is where I do the if and only if. So if line M is tangent to circle C, then M is perpendicular to CX, which in this case is our radius. And if I was thinking of the converse, I would go the other way. Ashley, what would the converse be? Yeah, perfect. That is our first theorem. And we're going to do an example with this theorem. So, is it a line? Is it a tangent line? That's going to be the question. Is this a tangent line? Let's draw a circle. Ooh, that was a bad circle. I feel like if I draw it and then add the center, it works out so much better than if I draw the center first. Okay, let's label our center K. And then I'm going to draw my radius out. So what do you want to call the radius point where they intersect? What do you want to call that? You can label it whatever you want, just not K. P? Okay, P. And then I'm going to draw a line. I don't know if this line is a tangent line yet. I don't know. But I'm just going to draw a line. We have to prove that this is the tangent line. Let's call it M. And then let's connect all these so we make what shape? Jody, what shape is this? What's the green shape? Right up here. What's this green shape right here? So we have a circle. What shape is this? Has 3 sides. Yeah, triangle. So we have a triangle. So let's label these sides of this triangle. We got 20, 21, and 29. There's a theorem that we used in the past that's going to help us figure out if KP is perpendicular to PM. If they're perpendicular, what should they have? What type? True. Very true. Even easier than that. They should have a what type of angle? 90-degree angle. So what theorem can I use to prove that this is a 90-degree angle? Yes, Pythagorean theorem. Carson, what's Pythagorean theorem? A squared plus B squared equals C squared. So if these two sides of these triangles are equal to each other, then we would have a right triangle. Yeah? Okay, plug it in. See what you get. Which side is C? Say it again. Yeah, KM. This entire length, which that entire length is how much? Yep, 29. Okay. Keep going with the rest. Okay, what goes on the rest of my left side? Mm-hmm. And what did both sides of these equal? Were they same or different? Same. What was it? 841 and 841. What does that tell us? Yes, where is my right angle? Is it over here? No, where is it? Yep, KPM. So it's right there on the circle where the tangent line connects with the radius. Great. We're getting up and doing more. And it's going to get harder as it goes. Yeah? Okay. I already picked out your groups. Ashley, Carson, Jody, you're in a group. Lily, Camille, Vincent, you're in a group. Raylene, you pick whatever group you want. Jody, that's your group. Do 1, 2, and 3. Yeah, I'm just going to show this to Drew, and then we can take it. Drew, these are the 3 problems that you have. Okay, that's it. How do I pause this thing? Let's how you prove a theorem. It might be a little difficult. Okay, theorem. 10.2 plus its converse states that if, okay, we're going to draw a circle first. Circle. And we have our 2 tangent lines. This one. And about right there. And I'm going to draw my 2 radius out here. Pretend this actually touched the circle. There we go. And these form 90-degree angles. Oops. As such. Let's label this A, B, P, and C. What 2 sides here are congruent? Say again? Yep, based off what we did on the boards, these 2 sides, because it's kind of a kite, and we would have solved it by helping us using the law of cosines, that those 2 are congruent. So that is what the theorem is stating. This is actually called the segment tangent to a circle theorem. That is what this theorem is called. I don't know why it's such a long name. So if 2 tangent lines of a circle meet at some point outside, so in this case it's A, meeting outside there, so they meet at the same endpoint, then the segments are congruent. So if trying to think how we should. If AB and AC are tangent to circle C, and meet at point A, this is an if and only if, so double arrows, then AB is congruent to AC. Alright, that's it with this. And we will have homework tonight. Except I will make it shorter than the other guy's homework. Oh, we only have 3 minutes. Homework 10.2, page 436. We'll do 9, 10, 16 to 20. Okay, we only have about